Hi, this is Vijay Vishwakarma.
Hi, this is Prashant.
Hi, this is Aksham. Hi. So today I'm going to talk about our project, and in this presentation we'll cover all the components we have used, the basic functionalities of our application. So we have created an end-to-end e-commerce application which we have named as Sail Along. So the application is for selling used boats and yachts and ships. So for this application, in this presentation, we're going to talk about how this application has been made, all the components, all the functionalities of the application, and the basic architecture behind the application. So we'll start with the components. As you can see, for NoSQL database, we have used MongoDB. For textual search system, we have used Node.js. For search system, we have used Elasticsearch, and for CDN, we have used AWS's Amazon CloudFront. For cache system, we have used Redis. Now we'll talk about the architecture of it. So our application, for our database of our application, we have used MongoDB as a database. Then we have used Elasticsearch, which create index and give the results of our query. Then we have used Redis for cache storage, and in Node.js, our application is deployed on Node.js, and over that we have also used a CDN provided by AWS, that is for the name is Amazon CloudFront. So it basically stores all the static content and gives us the cache information whenever we hit the application. So next we'll see MongoDB. So MongoDB we have used as a for the database of our web application. So in MongoDB we have used JSON kind of files to store in our database. So I'm gonna show you the database which we have used for using Robo 3T application. So in the collections under the products, you can see the different object, the details that we have created. So this is the basically the details of our product, the boats. So we have a boat ID, the image path, the title, the boat type and length. So we are using all these characteristics for the search query as well. So this was our database that we have created in Robo 3T. Now I'm going to show you the Amazon Web Services. So this we have used EC2, and we'll see our instances running in the EC2. So as you can see in EC2, under EC2 you can see there is one instance running, and when I'll click on the instance, we can see the description of the instance, the public DNS that we have used for the interaction between the database and the AWS server. So you can see MongoDB, under MongoDB the instance type is T2 micro. So these are the different instance type. It can be T2 large, T2 small as well. So in the description we can see all the details about our instances. This is the instance ID, and this is the public DNS that we have used to connect with our database MongoDB, and the instance for that connection we will be using public DNS. The instance status, you can see it's running. The type is T2 micro, as I just told you. So we'll go to status check, and you can see we can create a status check alarm. So basically it is a kind of alarm that we can create whenever the status of our instance changes, it can notify us, and then we'll see all the different characteristics that are being monitored of our instances. So you can see our CPU utilization and all these different things for monitoring the condition of the instance. Now I'm gonna talk about the textual search that we have used in our web application. So for that we have used Elasticsearch, which is another service of AWS. So I'm gonna go back to AWS homepage, then we'll look for Elasticsearch. So as you can see, there is one domain, and the name is Sail Along ES domain. The version is 6.2, and the cluster health is, as you can see, is green, and the configuration state is active. So we'll look at this domain, and we can see the domain status is active. So endpoint is basically used to look for the indices that we have created in the domain. And Kibana is we have used Kibana to make those indices. And the instance count is 2. The instance type is t2 dot small. So t2 dot small is basically this is what comes in the free tier system. So if we pay for it, so we can maybe use like t2 large or t2 medium, and it'll incur some cost as well. So the dedicated master is unable, you can see, and the storage type is EBS. So now we'll look at the cluster health as well, and you can see the status is green, the number of nodes is 5, data nodes is 5, primary shards is 5, and the active shards is 10. Now we'll see, look at the indices. So in the indices we can see one boards indices is running, the count is 51, and we just created this domain, so the query total is 0. So as we'll go through and search in our application, this will increase. Now we'll look at the boating, the details which we use for the searching things. So we can search through boat type, description, image path, and the data type is text for all this thing, length, price, title, and year. Now we'll look at the cluster health. You can see the cluster status green, the health is good, and we can look at these different characteristics of our cluster. As you can see, master CPU credit balance and all these things we can see. Now we can also look at the logs as well. In the logs we can we have the status is right now disabled, but we can enable it, so it will create the logs as well for these indices. So now Prashant will further tell you about the application.
Thank you, Saksham. Hi everyone, my name is Prashant and now I will be continuing with the cache implementation on our project. In this project, we have used Elastic Cache for Redis. Redis is a fast cache search as it stores data in its memory itself, so it takes lesser time to fetch out the data. Redis is an open source in-memory database which also acts as a cache. It is very highly available and reliable, so it is easily available to us. It decreases the access latency and also increases the throughput and eases the load of the database. Now I will be going through the implementation on our project. So let me go through the AWS services. This is AWS service platform, and under Elastic Cache we have already created Redis, which has a cluster, a node type, name cache.r4.large. This is a cluster which we have created, and by running it we can see the working of the cluster. After this, now I will be telling you about CDN, that stands for Content Delivery Network. Amazon CloudFront. It is a CDN service which is provided by Amazon, as CDN stands for Content Delivery Network. So Amazon provides a network which helps a user to get the delivery of the content which it is looking for. I will make you understand this in a simpler way through a simple diagram in the following slide. So this is a whole network architecture of a CDN where a user first requests the content from a web application through a URL which is sent to an edge location where generally all the data is collected because of the previous searches. In case the data which is searched by the user is not stored in this edge location, then this request is sent to Amazon server which has all the database set, and it gives back the request, the response, to the edge location from where the user can now access the content. In the future also, for other users or for the same user, this content is now filled in edge location, so whenever another user or same user ask for the content or search for a particular thing, the content can be accessed by the user on edge locations. So this is how whole CDN network works. And now I will be telling you about the implementation of this architecture on our project. So as you can see, this is the AWS service platform under which we are going to the CloudFront. This is the CloudFront homepage where we have already created one instance, and it has its own resource name and its own domain name. Apart from this, we can use these analytics reports which will help us to analyze the website more accurately. This is a cache statistics which shows the cache reports of our website. As you can see, May 6th, today day, and so on. Now my friend Vijay will take over the implementation of all these Redis and CDN on our project.
Thank you very much, Prashant and Saksham, for giving a great explanation about the services we have used. So now we'll move on to implementation part of these services in our project. We have used a MeanStack technology for creating the whole project. So MeanStack stands for MongoDB, Express, Angular, and JS. MongoDB is used to create the backend part, that is the database, and Express and Angular for the front part, while Node.js is used to deploy the code. It's an application server. So I'll just show you how we used various instances. So let's start with EC2, or which we have used to interact with the MongoDB database in our project. So when we look at the code, you can see that we have included various packages that are used to run the application. So you can see there we have included a package called Mongo Store that is used to connect to Mongo. And if you look down on line 27, you can see that we have included the DNS address that we got from EC2 instance in the mongoose.connect command or function. So if I show you the instance, you can see that we have a DNS right here. So this DNS we have included here so that we can connect our Mongo database to the EC2 instance. So this is how you connected the EC2 instance to our MongoDB database. So now if you look at the second part, we included Elasticsearch to do a search or textual search in our database to show the results of various products. So this I'll show you in the later part of the video, that how we use it. So now if you again look at the code, we have a function called Elasticsearch, which is used in the code. So this Elasticsearch instance, as on without the Elasticsearch service of the AWS, is useless. So I'll just show you the Elasticsearch service of the AWS as well. And when we go to the Elasticsearch service, we can see the sail along sail dash along that es dash domain cluster is active. So to interact with the uh, code, we have used this endpoint URL in our code. So if I go to Elasticsearch part in the index.js file, you can see that I have included various details about the code. So this is the access key ID that we get from our AWS account. If you go to AWS account and go to my security credentials, you can see we have here, we can see in the access keys, you can find your access key, and we have like this access key is still active. So we are using this access key to connect our AWS services to this account. So if you go to, you can see that we have created a client using Elasticsearch and the access key and all the stuff that is required, and host is the same URL that you have used in the endpoint. So this is how we connect Elasticsearch to the command. But before running this Elasticsearch, we had to create indices in the Elasticsearch. To do so, we just went to Kibana, that is this link. This is a Kibana is a tool which is used to create create indices in the Elasticsearch domain. So to create each indices, we have to use this command post slash boards, which is our index, and board is our type. So we are creating index for board. So we have to include all the variables that we want to search in the indexes. So this is how we created all the indexes of the various entries in our database. So now this is how we did the Elasticsearch. I will show you the search in the later part of the video. So this is how we connected Elasticsearch. And now the next part is how we use Redis cache. So Redis cache is, as my friend told you, that it's a fast memory accessible for running the queries faster. So to include Redis in our project, we used a package name module named Redis. So this Redis is also similar to Elasticsearch. Implementation of this Redis actually similar to the Elasticsearch part. We have included a client number and URL that we get from the Redis dashboard. So as you can see, if I switch to Redis dashboard, uh, just a second, let me search elastic cache. So Redis is a elastic cache type. So if you look at this, you got this endpoint. So we have just used this endpoint here, and that's it. So this is how we connect to the Redis cache, and we are using it in our project. So this is the schema that we have to define that to run the Redis cache. So now, since we have done the implementation, so the next part was to host the website. So we hosted our website on Heroku. So as you can see that if I switch to my Heroku page, we can see a website named Sail Along is hosted, and there's one deployment here. And if I keep open app, you can see the app. So there's another way to open this app. If I go to the AWS CDN CDN service that we have used to again provide the CloudFront, the content delivery network as content delivery network. So when I move to CloudFront, you can see we can see that we have a domain name available here. You can use this domain name as well to go to the site. And if I copy this and paste it here, you can see we have our website available. So if I reload it, yeah, here is our website. So this is our website looks like. So if you want to search anything, we can just type in any name. So for example, if I want to search for the boards that are manufactured in 2011, I'll just type 2011 and tap on search, and we can see that all the results for make equal to 2011 are visible. Another example is if we want to search for any board whose length is 52 inches. So if I type 52 and inch sign, you can see all the boards with 52 inches, 52 feet, 52 feet and 1 inch are available in the list. And so the next part is you can click on buy and add to cart. That we have implemented as an extra part, but it was not a requirement in the project. So another search result that I want to show you, that if you want to look for any keyword in description or title, like if you want to search star. So when I search star, all the results with star in their description or the title will be available here. I will run another search for you. For example, I want to search for a board with price tag like 25 billion, 1 lakh 25,000. So I'll just search here, and you will not get any result because there's no board search. And if you do a blank search, you will find all the result because the null character is found in every description or content. So you can see the various products or ports that we have available here. Now this is how we implemented all the Amazon Web Services in the project, and I had a great time doing this project. I learned many things. I worked on overall project with the contribution of my teammates. So thank you, Professor, for giving us such a great chance to do this project. Thank you very much.